Next, we're going to connect the non-configured ISL28022 to the dongle board. The two jumpers over here set the slave address of the ISL28022. ISL28022 can actually have 16 slave address from hex 80 to 9E. The software will actually go out once connected to the dongle board and sniff what slave address this board is configured to. The jumper at the bottom configures the ISL28022 to either receive a external clock or to pin out or send a interrupt to one of the green connectors or the terminators. And finally, the jumper called VCC Selects allows the user to either power the ISL28022 from the USB port or to select their own USB power. So now we will just connect the ISL28022 non-configured ISL28022 to the dongle board. I will restart the software. Once again, the dialog box comes up, or the window comes up. Connect to the device, and this time you see everything is enabled, and it did successfully sense the ISL28022, and the slave address is 82. I have nothing connected to the device, but just to show, I can measure. I can see the device is measuring something. It's floating the device input, so therefore you get irrelevant voltage. The measurement range, you can choose the measurement range. It can either be 60, 32, or 16 by choosing the combo box for the V-bus. And for the V-shunt, it ranges from 40 to 300 millivolts. The conversion time for the ISL28022 ranges from 84 microseconds to 68 milliseconds, and that can be selected by each combo box. Where my mouse is right now, this is for the V-bus, and this one is for the V-shunt. The loop delay input is, since the measurements are very quick, sometimes you cannot see when starting to do collecting data, you cannot see the numbers very clearly. So a user can actually induce a loop delay. 0.1 and start collecting. And as you can see, the measurement has slowed down, but yet the acquisition time hasn't. So the ISL28022 has a threshold detector. It's a digital compare, and it only senses the threshold or compares the voltage of the input to a level upon ADC conversion. There it is. As you can see, the dialog box comes up and you can set the thresholds. I have nothing connected to it, so I'll set the thresholds above what the actual levels are being measured. There's only one range for the threshold comparator, 0 to 60. So the values of low thresholds have to be between 0 and 60 volts. Anything above it, the backlight will turn orange, and anything below it, the backlight will turn blue. You can do this with the V-shunt threshold as well. Now, if you would like to, the user can actually connect the interrupt to the output pin, so you can send it to either a microcontroller or enable pin. And if you just wanted to see, you can force the interrupt to the pin itself, just to make sure it works. Bring it from a high to a low. Once the thresholds have been configured and the routing scheme of the interrupt has been configured, you press OK. Measure once, and as you can see, since I chose 40 and 50, the backlight for the V-bus turned blue. You can try the ISL28022 with an external clock or a system clock. By choosing the ISL22 external clock from the drop-down menu, you can actually enable the external clock, and configure the division frequency. So you can input about 4 megahertz of clock frequency into the device and divide the frequency down such that it matches the internal clock frequency, which is the internal system clock frequency when the external clock is not enabled. The native clock frequency for the 22 is 500 kilohertz. Overclocking the device will change the acquisition times, or underclocking will do so as well. Selecting the reset option from the ISL28022 will reset the device. And as you can see, remember we had 40 and 50 as threshold detectors. Now it's back from 0 to 60. To add a current shunt, or to enable the current measurements for the device, you press the current selection and enter in the sense resistor value. Since we have nothing connected to it, I'm just going to enter 10 ohms just to demonstrate that the current works. You measure once and you can see that at 300 microvolts you get 300 microamps at 10 ohms. To enable the power, just click the power checkbox. And again, the backlight will turn on and it measures 0 because V times I, 0 times current, is 0. If one needed to or wanted to save a series of data points, one can do it by going under the File drop-down box and pressing Save Data. Save Data will ask you to save a file. This will be the base file of your data. I'll say Data Demo. This will save it in a CSV format. Dialog box pops up and asks how many points you like to save. I'll save 100. And once I press OK, that's when the data collection begins. And as you can see, you saw the numbers flicker. And the data has been saved to the document. Under the dongle drop-down menu, you get a USB supply. If you ran the demo earlier, it's the same window used to run the demo. If a user wanted to configure a circuit around the dongle, with the I2C using an I2C and other and the power supplies that the dongle connector offers, one could, and then monitor the supply voltage. Under the dongle is I2C transaction. Again, if a user took the dongle and created their own board with another I2C device, they could send commands manually to the device and read commands manually from the device by choosing the I2C transaction. All right, so if the user from the RLoad connected didn't want to use the DCPs to source to exercise the power supplies being sourced by the dongle, they could easily switch out the routing of the power supply by selecting 2 and 3 of each of the headers, as shown here. As mentioned earlier, I put a modest load on the device just to demonstrate that it can measure more than just 2 milliamps of current. And once I measure once, you see 25 milliamps, 10 milliamps, and 10 milliamps. This concludes the ISL28022 starter kit demo. Hopefully you enjoyed it.